So thanks very much for coming up. I'd love to talk to you today about one of the core technologies that we are building at Ubuntu to make deployment of large-scale data centers easy. That technology is called MAZ, and it's basically a bare metal solution tool. My name is Christian Rees. I'm VP for Hyperscale and Storage at Canonical. I oversee basically all the next generation server work and our storage portfolio. I'll be talking this afternoon at 3:30 about our storage announcement that we did this week. Very exciting, including multiple technologies from multiple vendors, all backed by our support services. But today, or at this moment here, I'm going to talk to you about our bare metal solution. And I'm going to start actually far away from bare metal, just talking at a high level why cloud succeeded. And I think talking about cloud succeeding gives you framing about the potential that you have in your bare metal kit and how you can use it. So looking at cloud computing, there are two core drivers that I see as being the reason why cloud was a successful technology transition. First, it reintroduced this idea that you could do pay-as-you-go computing infrastructure like you did in the 60s and 70s. So when I went to university for the first time in the 90s, we're starting to phase out this idea of being able to pay as you go using terminals and batch computing. But cloud computing was interesting because it reintroduced this idea that you could start paying zero and then grow as you needed more infrastructure. But the second thing I think is more interesting, it solved a very common use case in a spectacular way. And addressing that use case is what led the cloud to actually growing. This use case is actually quite simple. Give me a new server to run this thing that I'm working on. So this is the typical dev and test use case, and it's primarily the reason why most of the OpenStack clouds deployed today are primarily for dev and test. It's because this use case here is of fundamental importance. Let's look at Bob's use case in a little bit more detail there. So he's asking to give me a new server machine, and if he's lucky, he gets to specify to his IT that he wants this much CPU, this much RAM, this much disk. He'll have a chosen operating system. Maybe it's what the enterprise determines that he's using, or if it's a bit more like the Wild West, they get to choose anything they'd like to use, maybe even Ubuntu. He'll specify how he wants the drives configured, if there's caching, if he needs LVM or RAID, because that's important for durability reasons or not, and on a specific network, because he wants to be on the DMZ or inside the QA lab, so he needs to specify where it is, with his credentials on it. So basically something which, once it's provisioned, the user can come and access it and start using it. So Bob's use case is fairly straightforward. He goes to IT and he says, okay, can I have this week? Okay, what about this month? What about in 3 months? So that was a typical IT experience for anywhere larger than 20 employees. You'd have to actually find someone in IT that wants to do the job for you in a hurry if you needed that done in a hurry. So the cloud, and Amazon is the best example of that, it completely nailed that use case. And I want to also say that Ubuntu is part of that by ensuring that you are able to deploy at zero or the lowest cost possible with the best experience possible. The work that we did in Cloud Init early on made the Amazon experience for the developer, or for this person in test and dev capacity, such a great experience. So what are the other things that the cloud introduced? This idea of pay-as-you-go, starting at zero, and that you had a new machine in minutes. So you basically said, push a button, and in a few minutes, you've got a full machine that you can deploy your software on, test it, and if you're running live, like Dropbox would do, you can have a new server up, servicing user requests in minutes, which you would never be able to do with traditional IT. Now, the way this was done in infrastructure as a service cloud was through virtualization. And the thing to ask of yourself today is, what does that use case actually have to do with virtualization? Virtualization enables it because it makes basically setting up that server a trivial operation. You don't have to actually mess with any hardware. But it also, because you're using Linux or a hypervisor to drive the cloud, it also lets you basically, just through the command line or through standard Linux utilities, fire up a whole new machine that the user can use. Wouldn't it be great if you could treat bare metal just like the cloud? So bare metal is trapped in the 1980s, right? It's IPMI, PXE, DHCP, DNS. That's where bare metal today is. But it would be fantastic if you could manage your bare metal just like in the cloud. This is the objective of MAZ, the technology that we deliver to Ubuntu users free of charge. So MAS stands for Metal as a Service, but today we just call it MAS because that's actually what the brand name is. It provides you with a cloud experience on bare metal. In other words, you can treat your bare metal as if it was a cloud. Instead of saying, I want that specific server, you can say that, but you can also say, give me a server which has this much CPU, or this much RAM, or this much disk space. It offers you a RESTful API, a web UI, and a set of embeddable libraries that you can use in your own application. If you have a management system or if you're offering a public service that wants to drive bare metal, you can embed MAS in it and drive bare metal directly. So people like SoftLayer, OVH, other bare metal clouds have technology similar to MAS. Ubuntu is now making that technology accessible to everyone through MAS. We have an incredible provisioner, the work of our amazing server team, which basically does image-based installs, which means that we install the operating system much faster than the native operating system installers do it. With SSDs and Ubuntu, you can get 2 minutes provisioning from scratch, which is pretty impressive, I think. With 1.7, we've announced now the inclusion of multiple operating systems. We built this initially for Ubuntu because we had very important internal use case drivers. I think Oil that we talked about earlier today, completely based on MAS, hundreds of nodes tracked in there. But we understand that, of course, people have lots of different operating systems deployed into their data center. They have VMware, they have Windows, they have Red Hat. And we want to make sure that MAS as a provisioner is useful for all those use cases. And so we have added in 1.7 the capability to deploy any operating system on a MAS cluster. We're using the same technology, basically writing out the image and doing configuration of it. This is a node listing from MAS, which basically shows, and this one is from Oil. So this is a node listing of MAS of the kit that is currently registered in Oil that's running there. You can see in the listing there that we've given you easy access to the number of cores, the amount of RAM, the amount of disk, and the MAC addresses there. And it's also cut up in different zones. So in a way, the zoning and the fact that you have all this metadata available there, the number of cores, number of RAM and disk, means you can treat this as a cloud. And I'll talk more about why the API makes that even easier. And if we manage to get the setup here working, we'll actually walk you through and show how the provisioning works and the details there. Yeah, sure. What is Oil? Okay, Oil is the OpenStack Interoperability Lab. It's one of the projects that Canonical has internally that does basically continuous validation of OpenStack in multiple configurations. So we work with a variety of hardware vendors, and we work with a variety of software partners that are providing extensions into OpenStack. Oil is what lets us do the mixing and matching or variation of those permutations and testing on top of it. It's what lets us give back to vendors the guarantee that your kit works in OpenStack as deployed by Canonical in combination with all these other technologies here. So if you are a SAN vendor and your customer has an SDN installed, does he know if that's going to work together? Well, Oil is a guarantee that Canonical provides that they will work together. And any signed partner with Canonical, there's an Oil add-on to that engagement that they can get into, and then that's really part of the offering that we provide. So what can MAS do? What are the key functions that MAS can do? Well, first it can discover new hardware. One of the things which is very annoying about racking kit is because you rack it up, and then you're racking 10 servers at a time. Then you go back and you say, which one is which? Where's the MAC address for that? Sure, some people will receive nice CSV files with all the MAC addresses and everything, but the reality is that the data center is a dynamic place. You're racking new kit, you're moving it around. What MAS can do for you is discover new hardware as it's plugged in. So the first thing that MAS does is it will boot up that server and install and run an ephemeral environment on it, which will detect all the hardware and which will set up IPMI credentials, or basically management credentials, that allow you to remotely control that server over there. So at the end of that first process there, we know what the machine is, a little bit about its hardware, and we can now remotely power control it, because without having to use default IPMI passwords and other abominations that are standard in some data centers. MAS can also configure the disks for you. So basically, you can say how you want the disks layout. Do you want Bcache on them? Do you want LVM setup? It will configure the networking for you. So if you want bonds, if you want jumbo frames, if you want specific VLAN IDs on the outgoing ports, you can do that as well. It will install an operating system. Pretty much our objective is to install any relevant server operating system. It will set up admin credentials for you. So essentially, it will let you at the end of that provisioning cycle, SSH into the machine, or it will hand off to DevOps automation. You can then, from that point onwards, control that bare metal as part of your DevOps infrastructure. We work together with Chef on doing first-class support for Maz and Chef together. This means that if you're a Chef user and you're using Maz, you can drive bare metal using Knife or using Chef provisioning like you would any other cloud substrates. We have the Chef guys here, and I want to call them up, but Massimo needs to tell me that I'm allowed to, and if not, well, in the end, well, they can talk more about what the work is and what they're seeing in terms of demand there. How does Maz actually do it? Well, the first thing, Maz packs in quite a lot of functionality in it. So if you are used to doing provisioning manually, in other words, you have to set up all the services yourself, etc., well, you have to set up a DHCP server, a DNS server, offer up TFTP, offer iSCSI for the nodes that are mounting a block, HTTP if you're offering an interface for people to be able to drive that infrastructure there. You have to then figure out how am I going to manage these machines. If you've got a variety of server kit like we do at Canonical, you need to support IPMI, but possibly ILO extensions, DRAC, Cisco UCS, things like Moonshots, even Intel AMT and ME. What Maz does is it probes and configures the BMCs and the PDUs, and it then remotely controls the machine power state, which is essential for you to be able to actually do the provisioning and then do deployment as well. We've got this image-based installer that I talked about, which is pretty unique, which writes out to the disk a full image and then does resize at the end of that. And Maz does one additional piece, which makes it ultra valuable, which is it will detect hardware component details and will auto-tag machines based on capabilities. So if you've got a machine which has a GPU, if you've got a machine which has a different architecture, Maz will know about that. It will tell you firmware revisions. It will tell you how many drives. If it's attached to a hardware RAID controller, fundamentally, Maz will tell you everything about that machine, and we'll keep that for you in a database. So you can see, okay, this machine had this configuration today, and it evolved over time. It models layer 2 and layer 3 networks and interfaces, so you can say, this machine has these interfaces. I want them on these networks over here. I want them configured as a bond with this VLAN ID on this interface here, and so it's on this network here. And so that allows you to, through the Maz UI, do all the stuff which today you have to do after you've provisioned, logging into the machine, tying things together, and hoping it works. And the last piece that Maz does, which is a great amount of great work that we've done for one of our customers that is using Maz in a multi-tenancy setting, is security commissioning. So when you decommission a machine, Maz will also wipe the drives for you, ensuring that the next user that comes along will not have an issue, will not have access to existing data on the drives. We offer, as I said, a cloud-style RESTful API, and this is the thing I think which distinguishes Maz from other provisioning systems at its core. The API is designed to operate like a cloud. So when you're talking to Maz, you don't say, install this OS on that machine. You can say, find me a node with these characteristics. You can provide CPU count, memory, and architecture, but you can also provide arbitrary tags that we set up for you. So you can say, give me a machine with a GPU, or give me a machine with an FPGA, or give me an ARM machine with 2 cores that has an SSD attached to it. So it gives you that ability to find in the data center what machines you actually want. It can, of course, install the operating system and boot. You provide to the start command just a parameter which says what operating system version you want. And if it's one of the supported versions that we have and the image is loaded inside Maz, it will boot it up. It can get node hardware and LLDP details. So this is how you expose that information that we detected when we did that commissioning step where we're doing hardware detection. And finally, it can do discovery of servers in a chassis. So we have support for new hyperconverged or ultra-dense chassis like Moonshot, like UCS. Those machines normally will have an interface which lets you query what actual blades or what nodes do I have installed inside this chassis. So Maz, you don't need to then go and individually configure all of those. Maz will probe the chassis controller, and it will tell you this is all we have. This is all the machines that you have in that chassis. We did the same for Microsoft for their OCP kit, and so we can also query the Microsoft OCP chassis and say, give me back what machines we have, give me back what MAC addresses are there, and then from that point onwards, you can treat that as basically accessible infrastructure that you have. We did our first release in 2012. It's the first generally available release, which was 1.2. 1.7, which was released at the end of last year, is what brought in Windows, CentOS, and RHEL installation. That 1.7 also brought full machine status tracking, and this is, maybe I'll do a parenthesis just to talk about why that's so important in a bare metal provisioner. The reason why the cloud was successful was also because hypervisors are a reliable way of controlling VMs. You can ask a hypervisor, start a VM up, and it will start that VM up. And you can ask a hypervisor, is that VM running? And it will give you an answer. Anybody who has direct experience with a variety of BMCs in this room here? So, okay. All right, so you people here who are like me living in the 1980s understand exactly. So BMCs can be single-threaded. You do a request. Oh, wait, I'm servicing somebody else's information. Or my monitoring system has just gone through, and I can't power the machine because it's servicing that request over there. So BMCs are notoriously unreliable. And in the end, your provisioning tool is the gutter of all your problems in your data center. If the BMC doesn't work, or if you have an issue with the installation, or the drives are dead, basically, your provisioning tool has to tell you about it, because otherwise, you have no idea what went wrong. I press this button, and I have no machine back. So the work that we did in 1.7 was instrumental towards actually tracking what is happening with the machine. Did we manage to boot it the first time? Did we manage to do hardware detection? Did it hang during an OS install? Did the MEM test succeed? Did we manage the firmware upgrade successfully? So MAZ is not fire and forget. We run through all the machine states, and we track what's actually happening with it. We give you basically a full dashboard which says, this is what the node state is, this is how far it's gone, it's hung here at this point, and we'll give you an alert if it takes too long. 1.7 also was a version that brought Chef integration as a fully supported system. So you basically, if you're using Chef, provisioning, or Knife, or Chef server, MAZ will integrate seamlessly into your environment. You can basically deploy any bare metal machine and control it with Chef. And 1.9, which is planned for the second half of this year, will bring out advanced networking and storage features and a redesigned, fully dynamic web UI. So 1.7 has one limitation, which is the web UI in certain circumstances won't refresh to give you back live information. In some places, you still have to reload. The main node listing and the node page do reload themselves, and so the individual elements will tell you this machine is now booted, it's running. But with 1.9, everything is dynamic. So if you're looking, for instance, at a network view, you'll see dynamically the nodes being added onto that network, and you'll see the network move or change as it goes. MAZ pricing, I want to have a pricing slide here because I'm a product manager. It is open source and free to use, and that includes the Chef and Juju integration. So if you're using Juju or Chef, MAZ is perfectly usable and fully supported by Canonical. It runs on all Ubuntu certified hardware, so we made an explicit decision inside Canonical to add MAZ certification as a requirement for certification testing. So if you're a hardware vendor that's working with Canonical, you'll have noticed that since 14.04, our requirements have changed. We now require your BMC to actually work. We now require your entire kit to be deployable with MAZ, which I think is the bare minimum in a cloud era where everybody's racking up tons of kits. But that is now part of our certification requirements, and so we are fully assuring that you will be able to deploy basically any machine that's Ubuntu certified with MAZ itself. What's available commercially? Well, you can get 24/7 support through our Ubuntu Advantage product, which covers basically all the product portfolio. You can deploy RHEL, Windows, SLES, and ESXi as an Ubuntu Advantage subscriber. If you're interested in using MAZ inside your own solution that you are going to export, talk to us about an embedding license, because the way that MAZ is licensed requires you to have an agreement with us in order to provide a public service. And any custom development. If you have a new piece of kit that we haven't worked with a vendor before, we can go out and talk to that vendor. If you've got interesting use cases in networking and storage that need to happen, then we're also happy to drive that there. What should you use MAZ for? So this is the tail end of the slide, but I actually want to just go back and think about what the actual primary use cases there are. So first, managing bare metal at scale. If you're here at the OpenStack Summit, it's because you care about bare metal at scale. And you may be hiding it behind OpenStack and using it directly through Horizon, but you still have to have bare metal deployed, and MAZ solves that problem perfectly. If you're doing web, storage, and Hadoop and other performance-critical workloads, which require bare metal access, you don't want to run Hadoop in a VM and suffer the virtualization overhead, well, MAZ is perfect for managing bare metal at scale, and it will provide you with a very easy path to running systems. It will allow you to replace homegrown provisioners. So if you yourself have this bolted together system like we had at Canonical, where you had Pixie, TFTP, iSCSI daemons running together, non-high availability, MAZ is a great solution to give you a robust provisioner in that data center there. this is a way for you to get a fully supported Pixie and operating system install, Pixie environment and operating systems install environments. If you're building your own bare metal cloud, MAZ was built to be embedded. The API is exactly for that reason, very simple. It handles exactly the embedding use cases, which are give me a machine, let me control access to it, give me feedback on what the status transitions are. So if you've got a GUI, for instance, you will live update how that commissioning or installation process is going. And at the end, if you want to deprovision, again, it will do secure wipe, so you'll have the guarantee that your disk is clean before you hand it to your next customer there. And at a high level, keeping your operations team happy. Abstracting bare metal complexity, as I said, is super valuable to people that have been working with unreliable hardware, unreliable protocols, as people that have used CSTP or Pixie, which is a combination, I guess, of DHCP and TFTP, have found. And this is, MAZ is a game changer in that aspect, because we're providing a freely available, fully supported solution that owns and is responsible for hiding all that complexity behind it. With that, I'm going to pause again to ask our spectacular solution architect. Can we go? All right. I think Massimo's telling me that he's ready to go. Yeah? All right. So let's show off the MAZ and Chef integration first. Let me hand this over to JJ. JJ, amazing Austin engineer. Like me, has a very newborn child in his house, so is suffering from lack of sleep. And when he travels, it's when he actually is able to do 7 hours straight. So JJ did all the work to get Chef up and running on MAZ for the first time. We did this for Chef Conf the first time. We announced it there. And I really want to thank you. You've been a fantastic partner to us. And let you drive the demo.
Hey, everybody. So there we go. Basically, what we're going to show here is the base. Oh, it's really small in the corner over there. This is us just listing out from the MAZ directly, leveraging the API. So I'm blaming the orange box for the brokenness, just FYI. It's pretty straightforward. It's basically goes in, you can run Bootstrap off of there, which will actually go ahead and install Chef after telling MAZ, hey, look, MAZ, I want this machine to Bootstrap. I have a, if you saw in the Chef slide a little while ago, that was actually the little screenshots that you took of my laptop actually running this stuff. So it was pretty cool. I love MAZ, I actually do. It works exactly how I was hoping it would, and it does the thing. I wish I could do the Bootstrap,
Except
but
when the machines are not running. Yeah, I can see what you're saying.
Exactly. But basically, the Bootstrap is just one simple command to say, hey, I want a new machine out there, and it'll boot it, install the OS that you're expecting to have, then go ahead and SSH into it if it's SSH, or if it's Windows, it uses WinRM, and then injects the Chef binary on there and actually checks in with your Chef server with your Knife RB and your validation PEM. So it's one step, you can do it. I'm putting a project together to actually build the Chef OpenStack cookbooks with MAZ as the top layer to the Bootstrap for these things. So if you're building OpenStack clusters over and over and over again, MAZ will be one of the drivers for that.
That's great. That's great.
So?
If they want to see this running, can they stop by the booth and take a look?
Absolutely. We'll have more than 20 minutes to to talk about this. And please find me. I'm wearing the blue shirt. Chef. Also, my boss Matt's here.
Do you have a booth here?
We have a booth down in what is it number? I don't even know. It's the one with the big chef on it.
It's impossible to miss.
Yeah. Any questions, or I can answer anything? It's also lunchtime.
How many Chef users in here?
Awesome.
Are any of you using bare metal automation today? Are any of you using bare metal today? Okay, interesting. So take a look at Chef. If you're interested, come in and talk to JJ. He'll talk to you about how the integration was done. There's a YouTube video that we did for Chef Conf, which we distributed there, that you can take and see it running in action. And downstairs, we have hardware which is behaving a bit better, and we can show it off to you. Do you want to do a walkthrough of MAZ itself, Massimo? Excellent. Are we out of time? Can we keep going? 4 minutes. Okay, 4-minute walkthrough.
Very good. Thanks, Vanna. So we have So I apologize, the hardware's not cooperating with us today, but I can give you the highlights, right? So there's different tabs at the top, and we have a new version of Maz that I can actually show if you would like or not.
You choose. You decide. What's the nicest to show? 1.8.
We'll go with the old version for now. So basically, you have the functionality on the right. You can, commission your nodes, and that's basically getting all the information. We can, if the nodes were cooperating and we had all the information, we'd have it listed at the bottom. So there's like a discovery. So you basically, you get down to the serial numbers or the firmware versions, serial numbers of the drives, the firmware versions, so you can update them. There's a lot of information. So Maz has a command line client and also an API, so you can actually query the API if you have existing auditing software that you need, to grab the information, for whatever reason, for auditing purposes. So you have full control again. You have node listings. Talking about the scaling, so Maz is set up as there's a region controller and cluster controllers, and here we have the cluster controller. We only have one running, but you can set up multiple cluster controllers. They do the caching, the package caching, and you're really limited by disk speed and bandwidth at that point. You can just add as many cluster controllers as you need to. There's an idea of zones, kind of like AWS, where you can split across an OpenStack. So if you deploy to zones, or if you deploy multiple machines, it kind of spreads them across the zone, so you have an increased or a lower chance of failure. The networking, so we can define networking and networks so Maz understands them. In the 1.8, I think you mentioned the IPAN functionality, where you can actually query Maz and say, hey, I need a block of IPs. Maz catalogs that and sends off the response back. Images, we have multiple architectures, multiple versions, not only of Ubuntu, but custom images like Windows, Les, CentOS, etc. So you can install multiple architectures, multiple operating systems. Here we have ARM64 and also PowerPC along with x86, obviously. Any specific questions about the user interface that I can answer?
That's a great question. Do you want to answer that? Or
No, go ahead.
Okay. So the images have to be specially prepared to be deployable with Curtain. So we deliver these images in the same mechanism through Simple Streams, which is how we deliver our cloud images on Ubuntu today, but they're specially treated in order to be able to be Curtain installable. There's an old legacy installer that uses Debian installer that will use the original, Debian installer bits, but the newer version uses a special image. Thanks very much for your time today.